explore the challenge that the traditional RAID will face and what benefits that RAID EE will bring you for solving the challenge. So, here's the content today. We will firstly introduce QSAN's RAID design quickly and talk about the shortcoming. Then we bring the solution, which is fast rebuild, and the difference between thin provisioning and fast rebuild, and finally explore the total benefits of RAID EE. Briefly speaking, it brings three key advantages: data availability, which is redundancy, better performance, and higher capacity. The applied application environment will be different according to the RAID level created on the RAID pool. For example, data backup or archiving will usually use RAID 5 or RAID 6. For application like virtualization, RAID 10 is recommended to be applied. The reason is that in random read-write environment, if the parity calculation is required to store or read data, while RAID 5 or RAID 6 is used, the overall efficiency will be much lower. However, in a general data backup environment, the number of data drives after a RAID 5 or RAID 6 RAID pool is larger than RAID 10, so the overall throughput will be relatively higher than RAID 10. According to different application environments, there is no best RAID level, only the most suitable. The cost of using RAID is higher budget. Because the relationship between broken hard drives can be hot swapped, such redundancy will require parity or mirror to be fault tolerant, which will result in a slightly higher cost. How much time does it take to rebuild a 2 TB volume? Today, if a RAID pool created by 4 hard drives is used, and the 4th hard disk is broken, the user directly hot swap the broken hard drive and replace it with a new one, and let RAID rebuild. The time required for rebuild can be seen. It is completely the performance on a single drive. It is assumed that the megabyte per second of a 7200 RPM hard drive is about 100 MB per second. So, the time required to rebuild a 2 TB volume is 2 times 1024 times 1024 equal to this number, and divided by 100 MB per second. So, it takes about 5.8 hours. The actual situation may be mixed with the uninterrupted I/O of the front end. Such an algorithm can only be used for rough estimation, for reference only. So imagine that the created volume is 100 TB volume. The rebuilding time will need up to 290 hours. Overall performance will be impacted during the rebuilding process. Even when the member drives are SSD, it was surely unacceptable for the environment to suffer performance degrade for over 2 weeks. It is necessary to figure out a better way to speed up the rebuilding process in the world. Imagine that the format just became 10 or even 50 times greater, and the rebuild time will be longer and longer. But in addition to using more redundant RAID configurations, QSAN also provides more advanced RAID functions. Fast rebuild. This function is literally targeting to accelerate the rebuilding time, and the way is very simple. Fast rebuild will only rebuild the blocks that have been written with data on the volume. Compared with the probability of failing the hard drives, the ability of filling up all the space of the large volume in the initial stage is very low, as you shall be able to recall according to your experience. User calls for help for drive replacement more often than the request of extending the existing RAID pool. Sometimes a RAID member drives get failed, while the pool usage is less than 50%. Here is the place where the fast rebuild helps to save lots of rebuilding time. However, this function cannot be converted directly. That is, the created volume cannot be modified to enable this function, and vice versa. The volume that has been enabled with this function cannot be cancelled directly. Besides, the volume with this function enabled is not recommended to be used in a random access replication environment. Thing not only inherits the benefits of fast rebuild, but also with the function of space reclamation. Using Thing can not only rebuild the space occupied by data, but also recycle and reuse repeated blocks to achieve the purpose of saving space. There will be about 10% to 20% attenuation in performance, just like fast rebuild. Of course, if the environment used by the user is backup only, then this impact is minimal. If it encounters a situation where the RAID pool space is full, it will cause the server to think that the data has been written while it is not. There might be data inconsistency incurred by then. Customers may ask very often, why am I not doing I/O? but all the hard drives are flashing. Okay, this is because the system is doing the action of 0-bit writing. This is no progress bar displayed on the system. The volume created may contain some old data, which cause the server's OS to misread it. At this time, you can use the Windows command prompt. Enter disk part. Select the corresponding disk number, and then use the command to clear the old metadata of a volume from the server side. Maybe you have heard of the so-called RAID 2.0 in the market. It is feature. The primary purpose of the RAID EE function is to reduce the overall rebuild time. The method is to directly add the spare disk designated for rebuild to the RAID pool and rotate it with the parity and data. At the beginning of construction, spare hard drives are added to the member of the RAID pool, and a block called S is added to perform strip rotation with parity and data block. Therefore, the performance of rebuild is no longer limited to a single disk. Each disk in the RAID pool needs to operate to perform the rebuild process. And the shortened time that this function helps will increase if you have more RAID EE spare hard drives added, which will help reduce the time by about 96% at most. First, after the rebuild is complete, replace the broken hard disk, and the system will start to perform the copy back process. Before the copy back is completed, if another disk is failed, it will be proceeding the normal rebuild process. Third, more EE spare will gain faster EE rebuilding process. Fourth, even RAID EE seems to have more spare disk than the traditional one, but it doesn't mean that the number of hard drives that can fail at the same time will increase. Okay, the workshop today is going to end up to sum up. There are the above ways to speed up the rebuild time, and this function can be used together. The recommended method is to use thin provisioning or fast rebuild at RAID EE. One is only to rebuild the space occupied by data and to make better use of space through reclamation. The other is the optimization of RAID EE for rebuilding time so that even if the pool space is full, it can be compared with traditional RAID rebuild speed.